In this session, we are going to deal with some problems based on nature of roots of a quadratic equation. Let us look at the first question. Find the value of k for which the quadratic equation has real and equal roots. So the quadratic equation given is 2x square minus 10x plus k equals 0. If a quadratic equation is supposed to have real and equal roots, it means that the discriminant should be equal to 0. So I need to first find the values of a and b, b and c. So comparing the given equation with ax square plus bx plus c equal to 0 gives us a is the coefficient of x square, which is 2. B is the coefficient of x, which is minus 10, and c is the constant, which is equal to k. I know that the discriminant is b square minus 4ac. This discriminant should be equal to 0 because the equation has real and equal roots. So now I can substitute the values of a, b and c. B is minus 10. So minus 10 the whole square minus 4 into a into c, that's k, is equal to 0. So 100 minus 8k is equal to 0. Solving this, I get 8k equals 100, which means k equals 100 divided by 8, which can be written as 25 by 2 or 12.5. So the value of k for which this quadratic equation will have real and equal roots is 25 by 2. The concept used here was again the discriminant should be equal to 0 for real and equal roots, and I found the value of discriminant and then I found the value of k. So pausing for a couple of seconds before moving on to the next one. Let's consider the next equation now. So the next equation is 9x square plus 3kx plus 4 equal to 0. So comparing this given equation with ax square plus bx plus c equal to 0, again they're asking me to find the value of k for which I have real and equal roots. So comparing the values, we get a is the coefficient of x square, which is 9. B is the coefficient of x, which is 3k, and c is the constant, which is 4. I know that for real and equal roots, the discriminant should be 0, which means 3k the whole square minus 4 into 9 into 4 should be equal to 0. 3k the whole square is 9k square minus 4 4s are 16, 9s are 144 is equal to 0. Which means 9k square is equal to 144, and this implies k square is 144 divided by 9. So k square is therefore equal to 16. If k square is 16, it means k is square root of 16, and therefore k is equal to plus or minus 4. So the value of k for which the given quadratic equation will have real and equal roots is plus or minus 4. Again pausing for a few seconds. Let us take the next equation now. Find the value of k for which the quadratic equation 12x square plus 4kx plus 3 equal to 0 has real and equal roots. So again, we need to find the value of k so that we have real and equal roots. We need to find the value of a, b and c again. A is the coefficient of x square, which is 12. B is the coefficient of x, which is 4k, and c is 3. I need b square minus 4ac is 0. So 4k the whole square minus 4 into 12 multiplied by 3 should be equal to 0. So 4k the whole square is 16k square minus 4 12s are 48, 48 3s are 144 is equal to 0, which means 16k square is 144. Therefore, k square is equal to 144 divided by 16 and k square is equal to 9. So if k square is 9, it means k is equal to plus or minus 3. So the value for which this quadratic equation will have real and equal roots is k equals plus or minus 3. Again pausing. Moving on to the next question. So find the value of k for which the quadratic equation 2x square plus 3x plus k equals 0 has real and equal roots. Again comparing the values, a is 2, b is 3 and c is k. So b square, that's 3 square minus 4 into a into c is equal to 0, which means 9 minus 8k is 0, which implies 8k equals 9, and that implies k equals 9 by 8. So the value of k for which the given roots has real and equal roots is k equals 9 by 8. We are using the same concept in all these questions. We are equating the discriminant to 0 because we need real and equal roots. Moving on to the next one. Find the value of k for which this equation has no real roots. So what is the quadratic equation that is given? The given quadratic equation is, so the given quadratic equation is x square plus 5kx plus 16 equals 0. Comparing this equation, comparing the given equation with ax square plus bx plus c equal to 0 gives us the value of a is 1 because coefficient of x square is 1. B is the coefficient of x, so in this case it is equal to 5k, and c is the constant which is equal to 16. Now I want the equation to have no real roots. So that means I want the equation to have imaginary roots. For imaginary roots are also known as unreal roots. So for imaginary roots or unreal roots, I know that discriminant should be less than 0, which means b square minus 4ac should be less than 0. Now b square is 5k the whole square minus 4 into 1 into 16 should be less than 0. This implies 5k the whole square is 25k square. Oops. 25k square minus 4 into 16 is 64 is less than 0, which means 25k square is less than 64 or k square is less than 64 by 25. If k square is less than 64 by 25, then I can say that k should be less than 8 by 5 and k should also be more than minus 8 by 5. So let me explain this idea in a better way. Let's take a simpler number. Okay, so let's take the number. Let's assume that I have to solve an equation which is, say, k square is less than 4, for example. So what I'm going to do is I'm going to take the number line and I'm going to plot the number line. Let's take the numbers minus 4, minus 3, minus 2, minus 1, 0 at the center, 1, 2, 3 and 4. When I say that k square has to be less than 4, you will notice that any number which is less than 2 has a square less than 4. That means the number has to be less than 2, right? It can be 0 as well. So you can just go ahead and check. 0 square is 0. So let's write that over here. Let's write the square in a different thing. 0 square is 0. 1 square is 1. 2 square is 4. So all these numbers that have been shaded here, all these numbers have their square less than 4. If you go beyond 2, you are going to have its square greater than 4. At the same time, consider the squares of negative numbers as well. So negative 4 square is positive 16, negative 3 square is positive 9, negative 2 square is positive 4 and negative 1 square is positive 1. So now you will notice that all the numbers between minus 2 and 0, all these numbers basically have squares which are less than 4. This means if k square is less than 4, then I can conclude that the value of k has to be less than 2 as well as the value of k should be greater than minus 2. Because any integer between minus 2 and plus 2 will have its square less than 4. You can try any number. You could take, say, negative 1.8. Negative 1.8 square is positive 3.24 and it is less than 4. You could take positive 1.9. So 1.9 square is 3.61, which is again less than 4. So when k square is less than 4, it means k is less than positive 2 and greater than minus 2. A similar technique has been adopted over here. So if k square is less than 64 by 25, I can say that k is less than square root of 64 by 25. Square root of 64 by 25 is 8 by 5. So k is less than 8 by 5 but greater than minus 8 by 5. So if you pick any number between positive 1.6 and negative 1.6, you will find that the squares of these numbers are less than 64 by 25. So this is the idea that we used in this particular problem. I am pausing for a minute so you can grasp this really well before I move on. Moving to the next question. So let's consider the following question. Prove that the equation as given over here has no real roots if AD is not equal to BC. So I have to now show that this particular equation has imaginary roots if AD is not equal to BC. The only way to find the nature of the roots is to find the discriminant of that root. So let's go ahead and find the discriminant from the given equation. So comparing the given equation with ax square. So I'm using capital A, capital B and capital C so as to not confuse it with the variables A, B and C used here. So I get A is the coefficient of x square, which is a square plus b square. B is the coefficient of x, which is 2 times AC plus BD, and C is c square plus d square. So now let's find the discriminant. Discriminant is b square minus 4ac. So let us evaluate. This is 2 times ac plus bd the whole square minus 4 times a times c. So let us go ahead and expand this. 2 square is 4, and then I have ac plus bd the whole square. The number 2 was squared here, and I have ac plus bd the whole square minus 4 times. Let's multiply these terms one by one. So a square into c square will be a square c square, and a square into d square will be a square d square. B square into c square will be b square c square, and b square into d square will be b square d square. Let's open up the brackets. This is a plus b the whole square, which can be written as a square plus 2ab plus b square d square, right? So this is a plus b the whole square minus 4 times a square c square plus a square d square plus b square c square plus b square d square. Now I'm going to open up the brackets and see if there are any like terms. So let's do that. 4 into a square c square is 4a square c square plus 8 times abcd plus 4b square d square minus 4a square c square minus 4a square d square minus 4b square c square and minus 4b square d square. So now let's combine the like terms. I believe 4a square c square minus 4a square c square will cancel. 4b square d square minus 4b square d square will cancel. So I am left with minus 4a square d square plus 8abcd minus 4b square c square. I can take minus 4 out as common, so I am left with a square d square minus 2abcd plus b square c square, and that is equal to negative 4 times ad minus bc the whole square. Because this trinomial is nothing but the expansion of ad minus bc the whole square. So this is the value of my discriminant. Now if AD is not equal to BC, can you imagine what will happen? If AD is not equal to BC, then AD minus BC will not be equal to 0. And therefore the discriminant will be negative 4 times square of some number. So square of AD minus BC the whole square. Because this particular part of the square is going to be positive. The square of any number is positive. So negative 4 multiplied by a positive number will always result in a negative number, which means that the discriminant will be less than 0. Let me repeat the last part again. I reached the conclusion that the discriminant is given by minus 4 times AD minus BC the whole square. Right? This was the conclusion that I reached. Now, if you notice, if AD is not equal to BC, then the term inside the square, the term that I'm underlining right now, this term will not be 0 if AD and BC are not equal. If it is not 0, then this square part is going to be a positive number. So negative 4 multiplied by a positive number will result in a negative number. So the discriminant is going to be less than 0, which implies that the roots are unreal. And this is what we had to prove. We had to prove that it does not have any real root if AD is not equal to BC. And hence we have proved this particular problem. If the value of AD was equal to BC, then this discriminant would have been equal to 0, and then you would have got real and equal roots. But because AD is not equal to BC, the value of discriminant is negative. So I will pause for a minute. There are various techniques of algebra that were used over here. I want you to take a look at all those ideas, and then I will move on to my next question. Moving on to the next question. So find the value of k for which the quadratic equation has real and equal roots. The quadratic equation given here is kx square plus k minus 5x equal to 0. So what I can now do is, I first need to rearrange this equation in the standard form. So I will rearrange it as kx square minus 5x plus k equal to 0. The coefficient of x square is k, so a is k. The coefficient of x is negative 5, so b is negative 5, and c is k. If the equation should have real and equal roots, the value of discriminant should be 0, which means negative 5 the whole square minus 4 into A into C is equal to 0. So 25 minus 4k square should be equal to 0, which means 4k square should be equal to 25 and k square should be 25 upon 4. K should be the square root of 25 by 4. The square root of 25 by 4 is plus or minus 5 by 2. So the value of k for which this quadratic equation will have real and equal roots is k equals plus or minus 5 by 2. Pausing for a few seconds. Moving on to the next question. So the question reads, find the value of k for which this quadratic equation has real and equal roots. So I can say comparing the given equation with ax square plus bx plus c equal to 0 gives us the following values of a, b and c. A is the coefficient of x square, which is 1. B is the coefficient of x, which is minus 2 times 1 plus 3k. And c is 7 times 3 plus 2k. Right? Again, please notice that the coefficient of x square is 1. So a is equal to 1. The coefficient of x is minus 2 times 1 plus 3k. So that's minus 2 into 1 plus 3k. And the value of c is the constant, which is 7 times 3 plus 2k. Therefore, for the given equation to have real and equal roots, so for the equation to have real and equal roots, I will say that discriminant should be equal to 0. So what is the discriminant? The discriminant is b square minus 4ac. This should be equal to 0. So what is b? B is negative 2 times 1 plus 3k the whole square minus 4 times a times c, that's 7 times 3 plus 2k. This should be equal to 0. Time to open up the brackets. Negative 2 the whole square is positive 4 into 1 plus 3k the whole square minus 4 sevens are 28. 28 times 3 plus 2k is therefore equal to 0. Time to open up the brackets. This is a plus b the whole square. That is going to be a square plus 2ab plus b square minus 28 3s are 84 and 28 2k's are minus 56k is equal to 0. So this becomes 4 plus 24k plus 36k square minus 84 minus 56k equal to 0. So now let us combine the like terms. So what we get is 36k square plus 24k minus 56k is minus 32k. And 4 minus 84 is minus 80 is equal to 0. Let us now divide this whole equation by 4. So we get 9k square minus 8k minus 20 is equal to 0. Now we need to solve this particular quadratic equation for k. So I can use the method of factorization. The product has to be 9 times negative 20, that's negative 180. And the sum should be minus 8. Not difficult to notice that it has to be minus 18 plus 10. 18 tens are 180 and 18 and 10 are separated by 8. So this becomes 9k square minus 18k plus 10k minus 20 is equal to 0. In these two terms, 9k is common. So 9k bracket k minus 2 plus 10 bracket k minus 2 should be equal to 0. Therefore, k minus 2 times 9k plus 10 is equal to 0, which implies k is either 2 or k is negative 10 by 9. These are the different values of k for which the given quadratic equation will have real and equal roots. So again, what I did was I first found the right coefficients. It is very important to find the correct coefficients of x square, x and constant. So I found the values of a, b and c, and then I equated the discriminant to 0 for real and equal roots, and then it was matter of algebra. So I used techniques like a plus b the whole square, combining the like terms, and then I got a quadratic equation in k over here, which I factorized, and I got my values of k. Now the only check that you should do in such cases is, we want to make sure that for these values of k, our equation still remains quadratic. So in this case it is quite simple. If you notice, the coefficient of x square is always 1. So no matter what the value of k is, this equation still remains quadratic. So both values of k are going to be valid over here. So again, let me pause for a minute before I move on to the next question. Moving on to the next question. So let us consider the next question now. Find the value of k for which this equation has real and equal roots. So let's compare the given equation with ax square plus bx plus c equal to 0. A is the coefficient of x square, so a is going to be k plus 1. The value of b is the coefficient of x. So if you notice here, the coefficient of x is minus 2 times k minus 1, and the value of c is equal to 1. Now for real and equal roots, discriminant should be equal to 0, because they have asked me for what value of k are the roots real and equal. So discriminant has to be 0. The discriminant is minus 2 times k minus 1 the whole square, minus 4 times a is k plus 1, times c, this should be equal to 0. Now negative 2 the whole square is positive 4 into k minus 1 the whole square, minus 4 times k plus 1 is equal to 0. So let's open up these brackets. So this becomes k square minus 2k plus 1. Let's open up these brackets. Minus 4k minus 4 equal to 0. So I get 4k square minus 8k plus 4 minus 4k minus 4 equal to 0. So therefore this becomes 4 minus 4 cancels. So I get 4k square minus 12k is equal to 0. Of course I can factorize this. I can take 4k out as common. So it becomes 4k times k minus 3 equals 0. This implies k is equal to 0 or k minus 3 is equal to 0. Or I can say that k equals 0 or k equals 3. So the values of k for which this equation will have real and equal roots is going to be k equals 0 or k equals 3. The only thing that I will now check is whether these values of k still make this equation quadratic. The condition for quadratic equation is that the coefficient of x square should never be 0. So the coefficient of x square right now is k plus 1. So the coefficient of x square is k plus 1. You will notice that when k is equal to 0, the coefficient becomes 1. And when k is equal to 3, the coefficient becomes 4. And therefore this equation still remains quadratic because x square's coefficient is a non-zero number. Therefore both values of k are valid, for which this equation will have real and equal roots. So I will again pause for a minute before I move on to my next question. Moving on to the next question. So let's consider the following equation. Find the value of k for which the equation x square plus k times 4x plus k minus 1 plus 2 equals 0 has real and equal roots. So now what I can do is I can first convert this into the standard form. I notice that the x part is missing. So what I should do is I should open up these brackets. So my equation becomes x square plus k into 4x becomes 4kx plus k into k becomes k square. K into minus 1 is minus k plus 2 equals 0. Now I can compare the given equation. So comparing comparing the given equation with ax square plus bx plus c equal to 0 gives us, let us now compare the coefficients of the given equation. A is the coefficient of x square, so a should be 1. B is the coefficient of x, so b should be 4k. And c is the constant, which is k square minus k plus 2. For real and equal roots, I know that the value of the discriminant should be equal to 0, which means b square minus 4 times a times c, that's k square minus k plus 2, should be equal to 0. So solving this, I get 16k square minus, let's open the bracket, 4k square plus 4k minus 8 should be equal to 0. So from this I can now find the quadratic equation for k. 16k square minus 4k square is 12k square plus 4k minus 8 equals 0. We can divide the equation throughout by 4. So 3k square plus k minus 2 is equal to 0. This is a quadratic equation in k, and now you can use the different techniques for solving a quadratic equation. So if you actually find the different parts or the different factors, you will get those factors as 3k minus 2 into k plus 1 is equal to 0, which implies k is either 2 by 3 or k is equal to minus 1. And hence the values of k for which the given equation will have real and equal roots is 2 by 3 or minus 1. Again, we just need to check whether these values of k retain this equation as a quadratic equation. Again, the coefficient of x square is positive 1. So this is going to remain a quadratic equation no matter what the value of k is. And hence we accept both these values of k. This is how we solve this particular equation. Let me again pause for a couple of minutes before I move on to my next problem. Moving on to the next one. Let's consider this question. If the roots of this equation are real and unequal, so when they say that the roots are real and unequal, it means that the discriminant has to be greater than 0, right? So the roots are real and distinct, which means discriminant is greater than 0. Prove that this particular equation has no real roots. So let us take the first equation. We have x square plus 2cx plus ab is equal to 0. This is the given quadratic equation. If I compare this with the standard form, so comparing the given equation with standard form, I get b square minus 4ac is, comparing this with the standard form, ax square plus bx plus c equal to 0. Let's see the values of a, b and c. So ax square plus bx plus c equal to 0. I know that the value of capital A is coefficient of x square, which is 1. B is the coefficient of x, which is 2c, and c is the constant, which equals ab. So the discriminant is b square, that's 2c the whole square, minus 4ab, which is greater than 0 in this case, which means 4c square minus 4ab is greater than 0, or dividing throughout by 4, I get c square minus ab is greater than 0. This is my first result. Now let's consider the next quadratic equation which is given. The second quadratic equation is x square minus 2 times a plus bx plus a square plus b square plus 2c square is equal to 0. So now again, if I compare the given coefficients, I get a equals 1, b is negative 2 of a plus b, that's the coefficient of x, and c is a square plus b square plus 2c square. So the discriminant again is b square minus 4ac, which is negative 2 times a plus b the whole square minus 4 times a times c, that's a square plus b square plus 2c square. So this is going to be negative 2 the whole square is positive 4 times a plus b the whole square minus 4 times a square plus b square plus 2c square. Let us now open up the bracket. So this is 4 times a square plus b square plus 2ab minus 4a square minus 4b square minus 8c square. So this becomes 4a square plus 4b square plus 8ab minus 4a square minus 4b square minus 8c square. Again over here you will notice that 4a square minus 4a square cancels, 4b square minus 4b square cancels, and therefore I am left with 8 times ab minus 8 times c square. 8 can be taken out as common. So this is 8 times ab minus c square. This is my discriminant. Now c square minus ab is greater than 0. So if c square minus ab is greater than 0, that is the result that I got from the previous equation, if you remember, right? So c square minus ab is greater than 0 implies c square is greater than ab. Shifting the ab to the other side, I get c square is greater than ab, which means ab minus c square is going to be negative because c square is a larger number as compared to ab. So ab is smaller and c square is larger. So a smaller number minus larger number gives you a negative number, which means that this discriminant is going to be less than 0. Because this discriminant is less than 0, I can say that the roots are going to be imaginary, right? And therefore it is not going to have any real roots. So the crux of this particular question was, from the first one I found out a condition which was used in the discriminant of the second equation. The discriminant of the second equation was 8 times AB minus C square. I know that C square is greater than AB, which means that AB minus C square is going to be negative. And because the discriminant is negative, I can say that the roots of the second equation are going to be imaginary. So this is how I proved this particular question. I am going to pause for a couple of minutes and we conclude today's session over here. Concluding today's session here.